announcements. Apologies for the confusion over PRC 117. There was some miscommunication with scheduling. A lot of you don't know where that is, and I didn't either until a few days ago. It's up in the Eleanor Roosevelt College, 440. Some maps to help you out. And once again, the midterm and final have been scheduled. Just jot this down or go back to the lecture notes and make sure you know the dates and time. Before we continue with our discussion of flow, I wanted to just review a few concepts that I noticed folks are having trouble with in office hours. If you guys want to take a look at this example of code and look in with what you think y is equal to. Why don't you take a little time to discuss this with each other? Keep in mind operator precedence. Part of the expression is going to be evaluated orders. Right? So, is that just be Okay, so let's take a look at this in more detail. When we get down to this line of code, the first thing that's going to be evaluated is this OR, right? And since both of these are non-zero values, for a logical expression, each of these evaluates to true, right? And we have true or true. So this whole thing evaluates to true, right? Whenever we have a true, for a logical expression, that takes on a numeric value of 1, right? And so now we have x equals 1, right? Which turns out is false. So as you're thinking through these types of expressions in your code, just keep in mind the data types that you're dealing with and the order of operations, right? That precedence table, which I'll show in the next slide, is really important to keep in mind.
Could you repeat the logic behind the
Sorry.
Could you repeat the logic behind the question?
Sure. So again, if we look at this line of code, right, we have the parens that clearly indicate the order of operation. So the expression within the parentheses is going to be evaluated first, right? And we have an OR between two expressions, right? And when we have an OR, this operator is looking at the logical value of these quantities, right? And since these characters have an integer value, right? And that integer value for A and B is greater than 0. Both of these are seen as true to the logical expression, right? So now this expression in the parentheses is evaluated to true or 1, right? And we're asking, is x equal to 1? Well, x also has a numeric value, right? That character has a numeric value, and that numeric value is not 1 in the ASCII table. And so now this whole expression becomes false, right? Because the ASCII value for b is not equal to 1. So a little bit of a tricky scenario, but really, these are really important concepts to keep in mind in your code. Okay, let's try another example here.
Question?
Yep.
Question of the previous one. I'm still I still understand why on the character line it sort of says asking you on the one it's like 0.
Yeah. So in a way, you can think of these. Every ASCII character has an integer representation, right? And so when we define in code a character with these single quotes, we're saying that whatever symbol we write here is the ASCII table equivalent, right? So to the compiler, to the computer, it actually interprets this single quote B, single quote as a number, right? So there's an underlying number always. Okay, I see we have a split decision for this next line of code. If you guys want to take 30 seconds to talk it over. Okay, great. So let's talk this one out. So when you look at this expression, you need to keep in mind your order of operations, right? And which operations have higher precedence. So it turns out that the equality operator, equal, has higher precedence than or, which means that this expression gets evaluated first. And so when we evaluate this expression, we get a false, right? Because B was equal to B. But then it looks at the second expression, which has a non-zero value. So the entire expression gets evaluated to true. Great. And just keep in mind this table. It's very useful to know this table, right? And as you code and work through the homework problems, hopefully a lot of them become second nature. And I just wanted to say one thing about homework, which is obviously homework counts for towards your grade, but beyond that, right? It's preparation for the exams, right? And as you're going through the homework, I really want to emphasize that solving the problems on your own, thinking through the problem solving, is really what's going to get you through the exams, right? I think using each other as resources for understanding syntax and kind of a lot of basic concepts we're covering in lecture is a great idea. But if you go to each other for deep problem solving solutions, you're going to have a lot of trouble in the exams, right? Lecture and discussion, we can show you examples, we can teach you the structure, but the only way you're going to learn how to problem solve is by trying it yourself. So, really what I meant. Okay. So some of you might have run into a problem with scanf as you're going through the homework and thinking through this. So here's just an example where we're initializing a couple of variables here. We ask the user to enter a number, and then we ask the user to enter a character. Now, keep in mind that the scanf is just taking in a single character, so equivalently you could have used a get part. Now, if we ran this code, and the program prints out enter a number, the user enters 8, and then enter as a character return, the program would print out something like this, right? It would skip over this second input, or it would appear to you as a user, and it would see as being equal to 10, right? So what's going on here? So it turns out that this first scanf, right, is only reading in up to the end of 8. And when the user presses enter, there's this implicit end line, which is an additional character. And so when we get to this next scanf, it's eating up this next character, which has the ASCII table equivalent of 10, right? So how could we avoid this issue and actually stop and wait for the user input? Well, if you remember, there was a simple option when you use scanf, which is to precede the format character with a white space, which tells scanf eat up all of the white space before looking for a non-white space character. So let's continue our discussion of control flow. We're going over conditional statements, and we had covered if else, switch case types of statements, and we have finished up with just starting to talk about the conditional operator, right? And I wanted to go over that again. So the conditional operator, if you remember, takes on this form. There's 3 expressions, a question mark and a colon, and this is an example of a ternary operator. So you've seen unary operators, operators that operate on a single expression, binary that obviously operate on 2 expressions. This is an operator that works with 3 expressions, right? It's a ternary operator. And if expression 1 is true, then expression 2 is evaluated, and the value of this operator, of this expression with the ternary operator, would be the value of evaluated expression 2. If expression 1 is false, then expression 3 is evaluated, and again, the value is of the entire operator is the value of evaluated expression 3. And let's look at a few simple examples. So if you wanted to calculate absolute value, your first expression would just check if x is positive. If it's positive, just return the value. If it's negative, negate the value, your absolute value. Similarly, if you wanted a min function, basically look at is x less than y. If x is less than y, return x. Otherwise, y is equal or smaller than x, so return y. Similarly, with a difference operation, which is an absolute value of subtraction, we need to just check the relative values of a and b and decide whether we should calculate a minus b or b minus a. And we could use these conditionals to decide what to print, for example, here. So here we're just using a modulo to decide if n is odd or even, and based on the value of this, print out odd or even, and so forth. So here we're using a conditional to decide on the value that should be printed out, and so we're just checking the value of n here. So in this example, right, if n is equal to 1, we would print out you have 1 item, and we wouldn't include the s at the end of item. If we have more than 1 items, we want to print out items. So then this conditional would evaluate to the character s, to the string s, and that would get appended to that text string. So it's important to know the precedence of this operator. As you saw in those earlier slides, precedence will make a big difference on what the actual population is. And the precedence for this ternary operator is lower than all of the binary operators we've seen so far.
Good question. Why does that have a %s when it says you have %d items?
Oh, so the %s is sorry, you guys haven't seen this format yet. This is a format for strings. So this conditional will evaluate to either the empty string or the string that is s. And so So this this third argument, the printf, would get slotted in right over there.
Okay.
So, yeah, again, this operates on 3 arguments, and that makes it easy to remember that it has lower priority. So let's look at another example. Let's say what we want is when n is greater than 1, we want to divide a variable x by 2. But when n is less than or equal to 1, we want to divide x by 4. So here we see an example where we're choosing what to divide by based on the value of n, right? So we have this conditional, but there's a problem here because of precedence, right? So remember that this operator has the lowest precedence. So what would happen here is we would evaluate this division first before moving on to this ternary operator. So we can solve this by introducing parentheses, and sorry, we can't solve this by introducing parentheses. So the operator itself is assuming that this operation is going to happen first, and so there are implied parentheses. So if we go back, to this example, right, because of order precedence, this expression, this division operator is going to be evaluated first. So we can put in these parentheses to be explicit. And so what happens in this condition, right, if n is greater than 1, this whole expression would evaluate to 2, right? But if n is less than 1, we have an error. And the reason for that is if n is less than or equal to 1, and these are all integer types, then we have a divide by 0. Right? So we can solve this problem by introducing parentheses around the ternary operator. And that would ensure that the order of operations is correct. Okay, so what do we do if we have multiple conditionals in a single line of code? We need to obviously know the associativity. And for conditionals, the associativity is always right to left. This is the same as the assignment operator, for example, but different than most of the binary operators that you've seen, like addition and subtraction. So if we have 2 conditionals here, what will happen is that the second conditional will be evaluated first, and then we'll move on to the conditional over to the left. Right? And it turns out that this ordering has a very natural interpretation, right? If you were to read out what this line of code is doing, what it's saying is if C1, so if C1 is true, then B1. Otherwise, we go into this second conditional, and we say if C2, then B2, otherwise B0, right? So even though the associativity is right to left, when you try to interpret the line of code naturally, you can read it out from left to right. So let's look at an example where we're interested in printing the ordinal form of non-negative integers. So the ordinal form is simply printing out first, second, and so on. So here we start off our code by declaring 3 variables, x, y, and z. We ask the user for a non-negative integer, and then we calculate the mod of that integer and set that set y equal to that. And then what we want to look for is special cases, right? So it turns out that 11 through 13 are special cases when you print out ordinals, So we want to treat these ordinals differently. So we want to make sure that they have the th ended to them. And so what you'll see is when we print them out, we're going to use this value, the z value, to make a decision. So the full printout is saying the ordinal value of our number is simply the number, and if z is equal to 1, then we should end with an st. If z is equal to 2, then we should end with an nd, and otherwise, if z is equal to 3, we should use, we should check if z is equal to 3, and if that's true, end with an rd, if not, end with a th. So there, for each one of these numbers, there's going to be a different assignment, right? So if we take a look at z here, again, we're checking if we're within this range. So if we're within this range, return 0. If we're not within this range, return the mod 10, right? Just give me the last digit. And so if the last digit is a 1, so 21st, for example, would end with a 1. We want to end our ordinal printout with an st, 21st. If it was 22, we'd want to end as 22nd, ND. And if it was 23, we'd want 23rd. However, if it's 11, 12, or 13, those are all going to end with th, right? 11, 12, 13. And so that's how that's what we're doing here. We're just checking to make sure that we're in that team range. Obviously, we need to put 0. Is this example clear, or should we go ahead? Okay. So obviously, conditionals are very similar to if-else statements. They're often interchangeable in your code. So how would you choose to use one or the other? So the conditional is more concise than an if-else, obviously, right? It's a more concise piece of code. And let's compare some examples here. So again, with our absolute value, if we wanted to do that with an if-else statement, one way to implement that is as so. With a conditional, we can be much more concise, right? So we can take these lines of code and embed the conditional right into the printf statement. Similarly, in this example, where we're making a decision as to how to assign c based on the value of n. This could be condensed to a single line of code here, and the functionality is equivalent. Now, given that the conditionals are more concise, why would we want to use if-else? There are cases where writing out the code as an if-else statement might make it clearer for you to parse later, for you to understand what your code is doing. The other reason is that if-else is often more versatile, right? So as you saw last time, you could include multiple statements following an if or an if or an else, which you wouldn't be able to do with a conditional. So let's revisit our round-off example again. So here we used if-else to round to the nearest integer, which is always where we needed to make a decision based on whether the number going in was negative or positive. So here we're just checking to see if x is positive, and if it's positive, we need to add 0.5 before casting as an int. If it was negative, we need to subtract 0.5. And we saw that this worked for both positive and negative numbers. Now we can rewrite this piece of code using a conditional. And again, now you can take this multi-line piece of code that calculated round-off and turn it into a single line of code, right? Again, we're just deciding in this first expression whether to evaluate the plus 0.5 or the negative 0.5. So, and it turned out we could express this a different way, which is that we could move the casting operator outside of the conditional. And the way to see that is that the value of this conditional would take on a double type, right? And so we could cast that double on the outside, just to avoid repeated code. And here's yet another format where we could move the addition operation outside and decide whether we're adding a positive or negative number. Okay, so we just talked about conditional statements, and now I'd like to move on to loops. Loops are ways to have repetition in your code. And there are multiple types of loop statements. There's a while, do while, for, and you can nest these loops, these different types of loops within each other. Let's start off by talking about while statements. So a while statement allows you, again, to execute a segment of code repeatedly with a decision. So here's a while loop, and what this while loop is doing is checking the value of n, and if n is greater than 1, it'll run this line of code, and after it runs this line of code, it'll check the value of n again. And if n is greater than 1, it'll keep running. Another type of loop that I mentioned is a for loop. This for loop, we'll get into the syntax in the following slides, but this for loop allows you to initialize a value. Here we're initializing either 1. Every time we go around the loop, we check if I is less than or equal to n, and we run this I++ operation. And again, this loop is looping over this this line of code, this for n times equals I. So each loop execution is called an iteration. And again, iteration continues as long as the loop conditional is satisfied. The loop conditional is just this for the while statement, the value within parentheses, and for the for statement is this middle expression. There are 3 types of loops that we're talking about. There's while loops, there's a do while, which is a slight modification of the while, and the for loop. And let's go into detail with each one of these types. So the while loop, the format is as such. We use the keyword while. We need these parentheses, and within the parentheses is the expression that we're evaluating. And then the next the next portion of the code is a statement. And if the expression is true or non-zero, the statement is executed, and we will repeat execution of this statement until the expression becomes false. And so that's very important to remember. Sorry, there's a typo here. Once the expression is false, we exit the loop and we proceed in our code as normal. So let's look at this in the flowchart format. So when we have some statements before we enter the while loop, once we hit this while, we check this expression. If the expression is false or equal to 0, we continue on with our program. If not, we execute the statement, and after executing the statement, we would check the expression again, and would keep repeating until this expression value is false. So the statement can be a compound statement, and as you saw last time, compound statements are simply written with the curly brackets. This allows you to have multiple lines of code within your while. So here's a multi-line example. So here we're declaring 2 variables, n and I. We're setting the value of I explicitly to 1, printing out number of lines, and then we ask the user for the number of lines that they want printed out. That gets assigned to the variable n. The while statement is checking to see if I is less than or equal to n. If that's true, then we print out the value of I. Once we print out the value of I, we increment I. And so what this code would do is, on every iteration, we're printing out the value of I and incrementing it. So there would be a list of numbers, of increasing numbers, up to the number of lines that the user entered, right? So we're going to exit this while loop once I is equal, once I is greater, than n. So once I is greater than n, we just continue on with our program and we'd stop printing out these numbers. So here's another way we could have written this, which is to include the increment operator in the printf. And since the plus plus follows, we would print out the number I and then increment I. So let's look at a few more examples of while loops. So let's say we wanted to calculate the sum of the numbers from 1 to n. So here the user will enter in what n is, and then we'll run this while loop. Again, we're initializing I to 1, and we're initializing a sum to 0. And so on each iteration, if I is less than or equal to n, we increase the value of sum by I. Then we take I and increment it. So you can see how this would, on each iteration, we'd be adding an additional digit in our sum. And then finally, we print out the value of sum. So here's a more concise way that we could have written the same piece of code. Again, we're declaring and initializing our variables in the same way, taking the same number, but we just have replaced these two lines of code with a single line of code. So we use the plus equal operator to add I to sum, and we're using the delayed increment here, so I won't get incremented till after sum is increased. Let's say we wanted to calculate the value of a to the n. Again, we can do that with a while loop. We ask the user for the values of a and n. We've initialized power to 1 and I to 1 as well. And what we can do is, on each iteration of the while loop, again, we're incrementing I at the end of the loop, but before we increment, we're calculating we're calculating another a applied to power. Right? So if I was equal to 1, this loop would only run once, and power, since it was initialized to 1, would be equal to 1 times a, which would be a. If the user had entered n as being 2, we would go through this loop twice, right? And so on the first loop, again, power would get set to a, but on the second loop, we would have a times a. And you can see how every iteration we're multiplying by a. And here's just a more concise version of the same functionality. Here we're using delayed increment in the expression. So we're checking this condition before we increment I. And then we can just have our single line to do the multiplication. So increment is very important in all of these while loops that I've shown you. So in that last piece of code, remember we were incrementing I++ with each iteration. What would happen if we didn't increment? So if we didn't increment, let's say we commented out that line of code, the value of I would remain static, right? And we would be stuck in this loop forever, right? It would be an infinite loop. And behaviorally, you'd see this as the computer hanging, right? The computer would just keep printing out the value of I, which is never getting incremented, so you just see the number 1 printed again and again and again. So these are infinite loops, which should be avoided. But if you, if in the process of writing programs, you get stuck in an infinite loop, let's say you have a bug in your code, if you're on IM6 or on a Linux machine, you can stop that infinite loop by typing Control-C, holding down the control button and hitting C. This will tell Linux to exit your program, and you'll be back at the command prompt. Okay, so let's look at another example. Let's say our task at hand is to prompt the user for a positive integer, and we'll keep repeating while the user complies to this request. When the user enters a non-positive integer, we want to output the average of all of the previous positive numbers. Right? This is a task we couldn't do before we had this looping functionality. We'll see how we can use loops to help us. So we need a few specific data structures in our program. We need to keep track of the count, how many positive integers the user entered, and we'll also keep track of the sum of those integers. So we start our program, we declare count and sum, and we have to initialize them. Obviously, initially the count is 0 because no numbers have been entered, and the sum is 0 because we haven't added any numbers. We're going to also use an additional variable that we use as an indicator, and that indicator will get checked on as a loop. We need to initialize it to 1, because the way we're checking it is we're saying if next is greater than 0, then we'll run the loop. And obviously we want to run the loop the first time. This you can think of as an artificial initialization, because as you'll see, we'll be setting next based on the user input within this loop. So we start off, we ask the user for a positive integer, we take in what they've entered,